mathematicians. In this video, we're going to walk through how to find the GCF of numbers and then also how to find the GCF of monomials. I'm going to show you a technique where we're going to use the prime factorization as a tool to find the GCF. So to get started, what I'm going to do is write each of the numbers as its prime factorization. All right, for 12, I know 12 is 4 times 3, and I know 4 is 2 times 2. So the prime factorization of 12 is 2 times 2 times 3. What about 30? I know that 6 times 5, and 6 is 2 times 3. So 30 is 2 times 3 times 5. For 42. Now another option, if you sometimes you could do them in your head. If you ever feel stuck, come to a factor tree. And I know 42 is 7 times 6, and I know 6 is 2 times 3. So there's my prime factorization, 2 times 3 times 7. Once we have the prime factorization, we want to find the greatest common factor. So we want to find what prime factors all three numbers share. So I see that they all share a 2. They all share a 3. And then what's left over is a 2, a 5, and a 7. All right, so that's all that they share. So that means that the GCF of 12, 30, and 42 is 2 times 3, which is 6. Now, the nice thing too, once we have the GCF, is it's really now easy to write each number as a product of the GCF. So 12 is the same as 6 times, well, what's left over in the prime factorization? A 2. 30 is equal to 6 times, what's left over in the prime factorization? A 5. And 42 is equal to 6 times 7. And we can also look and see these factors that are left that we're multiplying 6 by, they have no factors in common other than 1. So we found the GCF and we've written each of the numbers as a product of the GCF. Let's use the same strategy now, but instead of numbers, let's try it on monomials. Let's do the same process, but now we have monomials that we're going to find the GCF of. I'm going to do the same technique where I'm going to start by writing the prime factorization of each one. So I'll start with 20, x to the 4th. 20. 20 is 4 times 5, and 4 is 2 times 2. So 20 is 2 times 2 times 5. The prime factorization for a power is simply going to take that and expand it out. So x to the 4th is x being multiplied by itself 4 times. Let's do the next one. 40x squared. Let's see, 40 I know is 4 times 10. This is 2 times 2, and this is 2 times 5. So my prime factorization of 40 is 2 times 2 times 2 times 5. The variable x squared, x is being multiplied by itself 2 times. I'm expanding out that power into repeated multiplication. Finally, 60x cubed. When I think about 60, I have 6 and 10. 6 is 2 and 3. 10 is 2 and 5. Okay, so 60 is 2 times 2 times 3 times 5. And x cubed expands out to x times x times x. So prime factorization, we're looking at the prime factors of the number and then expanding out the powers. We'll go through the same process. Let's find all the factors they have in common. Right off the bat, I see they all share a 2. Okay. They all share a second 2. And they all share a 5. Okay, good. Let's go with the variables. They all share one x, and then they all share a second x. So this means our GCF is going to be whatever 2 times 5 times x is. And that is 20x squared. So I think often getting it into the prime factorization, it's helpful for us to find all of the prime factors, whether they're numbers or variables, that they have in common, and all of them have to have them in common. Let's do the next step now of writing each of the monomials as a product of their GCF. So 20x to the fourth is 20x squared. And what I need to multiply it by is whatever was left in the prime factorization, x times x or x squared. Let's do 40x squared. That's 20x squared times, let's see what's left over, just a 2 times 2. And then finally, 60x cubed is 20x squared times what's left over here, a 3 and an x times 3x. You can always double check yourself by multiplying them together. 20 times 3 is 60. X squared times x is x cubed. So you can always double check by going in the other way. I hope you found this video helpful. Just a few techniques of how you can find the GCF of either numbers or monomials. And by breaking it down into its prime factorization and looking for what factors they all have in common. Don't hesitate, send me an email or come to Math Lab or ask me in class if you have additional questions.